we're solving problem 14 from the Spring 2021 AMC 12B. Let ABCD be a rectangle and let DM be a segment perpendicular to the plane of ABCD. Suppose that DM has integer length and the lengths of MA, MC, and MB are consecutive odd positive integers in this order. What is the volume of pyramid ABCD? So here we have MA, MB, and MC, all the segments. So A is the original odd integer, and then MC is the second one, and MB is the third one. Why do we add 2 and then 4? The intuition behind this concept is that if you have an odd integer, let it be 3, to get to the next one, you have to do, the next one is 5, correct? So to get to the next integer, you have to add by 2. So to get to the next odd integer, you keep on adding by 2 for this reason, to get the 3 consecutive odd integers. So now, and also we want to establish that this lowercase d is our height for this part. So we can start solving this problem. We can use the Pythagorean theorem on triangle MAD. So and this yields AD, this length squared, equals A squared minus lowercase d squared. And well, look at this vertical triangle MBC or MCB. It's still a right triangle because when you look at it from the top, the angle it's making from segment MC to CB is a 90-degree angle. So we can solve for BC. BC squared is equal to A plus 4 squared minus A plus 2 squared. Since these two segments are the lengths of the rectangle, we can set them equal to each other because they are equal to each other. So A squared minus D squared is equal to A plus 4 squared minus A plus 2 squared. This right side yields 4A plus 12. A squared minus D squared. We cross out 4A from both sides to get A squared minus 4A minus D squared is 12. Since we have these two A terms, we can use various methods from algebra to complete the square. So we want to add 4. So this is A squared minus 4A plus 4. This is how we complete the A square, or the square for the A, and we want to do this so that we can later incorporate the minus d squared in a difference of squares equation. So this becomes A minus 2 squared minus d squared is 16. Now that both of these terms on the left-hand side are squares, we can use the difference of squares. So A plus d minus 2 times A minus d minus 2 is 16. 16 can be broken down. 16 can be broken down into 4 times 4, 8 times 2, or 16 times 1 in integer components. We can immediately knock out 4 times 4 from our possible solutions here, because then d, well, this wouldn't even make sense. If you add d and then subtract the d and expect the value to be the same, well, there's all other constants, means something's wrong. Something's probably it suggests that d is 0. And then 16 and 1, this is wrong because the factor of 1, since we subtract 2 and 1 is obviously less than that, or this would just not work because 16 is too great and 1 is too small in this case. That leaves us with 8 and 2. Now obviously when you add d, we set it to 8. But when you subtract d, you set it to 2. Because in this case, if they're positive integers, accounting for geometry, since you can't have negative lengths, these two are the segments, in fact. And you solve for a and d. So there's a possible pair. A and d is 7 and 3. Well, we solved for a and d. We have to solve for the volume. And what's the volume? It's just of a pyramid. A pyramid's volume is 1/3 times the base area, like the rectangle in this case, times the height. So what's the base area is we want to find. AD is one of the side lengths. How do we get AD? We use Pythagorean theorem again. From here, we know that this is the square root of a squared minus d squared. So this is the square root of a squared, which is 7 squared, 49, minus 3 squared, which is 9. Take the square root. You get that AD is square root of 40, or 2 root 10. And the other length, DC, well, you can solve it with this triangle. So DC is equal to, this is a plus 2 squared. A plus 2 is 9, and then 9 squared is 81. And then subtract the height squared, which is 3. 3 squared is 9. Take the square root. This is square root 72. And all you want to do is just 1/3 times 2 root 10 times square root 72. I know square root 72, you can like simplify it down more, but you just want to factor out and then multiply everything. So, and then you multiply the 3 because that's the height. D is equal to 3. These 3's then cancel out. So the square root of 2 root 10 times square root of 72 is going to be your answer, which is 24 root 5. So that's the volume of this pyramid.